Let's discuss React security and best practices. This presentation will cover essential techniques to secure your React applications against common web vulnerabilities. We will explore different facets of security, from preventing cross-site scripting attacks to managing dependencies securely. One of the most common web vulnerabilities is cross-site scripting, or XSS. In React, it's crucial to avoid patterns that can introduce XSS vulnerabilities. A particularly dangerous practice is using dangerously set inner HTML. This property allows you to directly set the HTML content of an element, but it bypasses React's built-in escaping mechanisms. As you can see in the code block, avoid using this property at all costs. If you inject unsanitized HTML from user input or external sources, you are opening your application to XSS attacks. The safe approach in React is to let React handle the rendering of text and data. React automatically escapes values rendered within curly braces, which prevents XSS attacks by default. As shown in the first code block, simply rendering user text within a div element is a safe way to display content. If you absolutely need to render HTML content, consider using a sanitization library like Purify. These libraries can parse and sanitize HTML to remove any potentially malicious code before rendering it in your application. Remember to sanitize any HTML that you get from the user end. Validating user input is another critical security measure. Always validate the format and content of data entered by users to prevent unexpected behavior and potential exploits. This example shows how to validate an email address using a regular expression. Implement input validation on both the client side for immediate feedback to the user and on the server side for robust security. Never trust user input. Always validate. Environment variables are a key part of securing your React application's configuration. When using Create React App, only variables prefixed with React App _ are exposed to the client-side code. This prevents you from accidentally exposing sensitive information, such as secret keys, in your client-side bundle. As you can see in the code block, use React App API URL, not just API URL, in order to use the environment variable safely. Never include secret keys or other sensitive credentials in your React application. Keep them on the server side. Always use HTTPS in production to encrypt data transmitted between the client and server, protecting it from eavesdropping. Configure cross-origin resource sharing, or CoRS, properly on your server to control which domains are allowed to access your API. This prevents unauthorized access from malicious websites. The code block shows an example of how to configure CoRS in a server-side application, specifying the allowed origin and enabling credentials if necessary. Authentication and authorization are fundamental to securing your application's access control. Use secure methods to store authentication tokens, such as HTTP-only cookies, which are not accessible via JavaScript. Implement protected routes to ensure that only authenticated users can access certain parts of your application. This code block demonstrates a protected route component that checks if a user is authenticated and redirects them to the login page if not. Managing your project dependencies is crucial for security. Regularly audit your dependencies for known vulnerabilities using tools like npm audit. This command scans your project's dependencies and reports any security issues. Use specific versions of dependencies in your package.json file to avoid unexpected updates that could introduce vulnerabilities. Avoid using wildcards or range operators that allow automatic updates to newer versions. Content Security Policy, or CSP, is an added layer of security that helps to detect and mitigate certain types of attacks, including cross-site scripting. CSP is implemented by adding a Content Security Policy header to your server's HTTP responses. This header defines a whitelist of sources from which the browser is allowed to load resources. By restricting the sources of scripts, styles, and other assets, you can significantly reduce the risk of XSS attacks. Here's a quick recap of the key security practices we've covered. Prevent cross-site scripting attacks by avoiding dangerously set inner HTML and using sanitization libraries when necessary. Implement robust input validation on both the client and server sides. Securely store authentication tokens and other sensitive data. Regularly audit your dependencies for vulnerabilities. By following these guidelines, you can build more secure React applications and protect your users from potential threats. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.